هكا تنجم
Yeah,
نشوف
gorgeous. Okay,
الإكرام.
I'm gonna do an introduction first. موافق.
جست قبل الانترو كونفيرمي لي اسكو تنجم نشوف السورس كود لنا.
Yes.
Okay.
Okay.
Hey.
Good.
Yeah, that's good. Okay. Okay. So good evening, everyone. Thank you for being here. So my name is Taha Saifi. I'm the project manager at Data Science Club TBS, and today we're going to be having the deep trading workshop. So in case you're attending one of our events or workshop for the first time, so I'm gonna do a quick introduction to the club. So Data Science Club is data science, basically student organization that was founded in 2020. And we aim at creating and enhancing a data science culture inside TBS, and why not within Tunisia in the long run. So yeah, we usually do this through a series of workshops and events that are DS and AI related. We also had a data camp. So yeah, that's it. That was a quick introduction. So without further ado, I'm gonna move on to Mr. Muwafaq Ayedi. So he's our mentor for tonight's workshop. He's a data scientist at Adobe HF and Google Africa Developer Alumnus. Did I say that right?
Yes.
Yeah. Okay, great. Okay, so Mr. Muwafaq, the stage is yours. So would you start first by introducing yourself, which I already did, by the way.
Okay.
Would you start by introducing yourself and then like outlining the workshop agenda, what you're going to be doing, the coding part, everything, preferably also explain the context and usefulness of the project, because some of the participants may not have a sound financial background. So yeah, best of luck, the stage of yours. Thank you.
Okay, thank you, Taha, for the introduction. I just have one question. Do I keep speaking English for the next 2 hours, or what do you want to choose?
I guess we don't have foreign participants, so like whatever suits you, maybe. If you want to explain Tunisian or in English. I had to do the intro in English because we're basically an English-speaking school, so it's kind of some English.
Okay,
please.
so
okay, one of our participants. Okay, I said English, please.
Okay, great. So hello everyone, my name is Muwafaq Ayedi. Before starting the workshop, I want to thank you for this invitation. Once again, it's a pleasure. So like Taha said and introduced me, I prefer to introduce myself by saying I'm an IT activist, and I like IT related stuff. I like coding, and tonight's workshop is about predicting the Tunisian stock market, specifically the Tunisair stock values. So do not be afraid. Finance is not that scary. It's not difficult, and the context is. Lately, in the past couple of months, Orfa Hamdi became the CEO of Tunisia, and finally we had an engineer, a high-profile engineer that took over the company. So the stock of Tunisia went to the roof, and it was interesting to try to predict what's going to happen after that. And you know Tabubi, he's a great person, and he removed her and put somebody that we don't know, and most probably we will see his performance in the next couple of months. So when we talk about finance, we talk about endogenous and exogenous variables. So we have variables that we can like predict, if like how many Tunisair planes tomorrow will fly. We can know that. How many kerosene we're gonna put in the airplanes, and if there is like a kerosene shortage, is gonna affect Tunisair flights. But there are political movements that influence the stock market, and those political movements that heavily influence the value of Tunisair stocks. And that's why this is very interesting. So you do not need a financial background. I'm not a finance guy. I'm a software engineer, but I'm really interested in stock market. And the data we're gonna treat tonight, we will not go in depth of the highs and lows of the stock value of Tunisia, but we're gonna just program a program that can predict what's going to happen without us knowing what happened in the last couple of years. So before doing any data modeling, and after a consultation with Worklab, the request was to implement a real-life project, an end-to-end real-life project. And when we are talking about artificial intelligence, the first challenge that comes to mind is data gathering. From where I will get my data? Is it downloadable on the internet? Am I going to scrap the data, or the data is going to be provided by the company I work for? It's not known in advance, so we need to make our research. And this is the difficult part. People think that modeling is the difficult part. No, the difficult part is how to acquire the data. And once you have the freedom and you have the tools to acquire data, for example, by web scraping, which will be our main topic tonight, you're going to feel the freedom of having your own data. You will not be always dependent on what people post on Kaggle or share on other platforms. So what we're going to do is an end-to-end machine learning project. And hopefully it's going to be a prototype, because an end-to-end take a lot of time. But at least we're going to talk about the end-to-end machine learning project, this small project. Usually it takes a couple of months, and we will try to do it in 2 hours. So implementing our machine learning model will not be the subject of tonight, but we will try to cover some. And some parts I was like developing them by myself during this week. So we do not waste a lot of time, because it takes a lot of hours of preparing. And something comes to my mind right now. If you have any question, please open your microphone and ask me right away. Do not be shy. I'm seeing Mariam Ahmed Ali. I'm attending from Lebanon. Hello, Lebanon. How are you doing? That's encouraging. So, what was I going to say? I try to automate some processes, so we do not like do copy and paste and all those stuff. I try to code them, and every time I'm surprised. Like I said to myself, it's gonna take 1 hour or 2 hours, and then it takes much more. So tonight is a process of me thinking about how to implement this in front of you and show you how like small prototypes of codes. Sorry for not sharing my webcam with you, because like I was telling the guys, topnet has shut down for me 2 hours ago, so I'm on my mobile data, and it's Tunisia Telecom, and it shuts down sometimes. So do not freak out if you see me out. I will be back like in when Tunisia Telecom decides for me to be back, which is usually around 5 minutes. But hopefully nothing wrong happened. I'm shutting down my webcam because it takes a lot of data. So let's start. So guys, to gather our own data, what do we need? We need a couple of softwares. You are not obligated to follow me during this workshop. Just watch what I'm sharing with you. So one of the best tools over there is a test and automation tools for websites. It's called Selenium. Selenium is used, so when you have a website and you want to make testing the website automatic, you use Selenium. But as an IT community, we discovered that it's really good for gathering data from any website, almost any website. I think for small exceptions like Facebook, they use a hell of a technology, so we cannot like scrape it. But it works most of the time on most websites. So the first step is to go on the web, and I'm going to show you, but please do not waste the effort and your effort and follow me, because it takes a couple of hours to set all these things up. So you're going to download the Chrome driver, which is like a robot. that can log into any website, do anything that a human being can do. Chrome driver can do it, and then you're gonna download the version compatible with your own Chrome version. So this is Google Chrome that you use and that I hate and don't use. And you need to make sure that the version of your Google Chrome version is like Chrome driver. Okay, so this is the first step. These are the versions. Last night I downloaded a new one because mine was old. I think it's 92. I think it's 91. And then after downloading Selenium, I'm gonna put it in where I'm gonna put it. I'm gonna put it in the project folder. So I have here Chrome driver and I have extracted in here. And now my source code on this IDE will be he can access the Chrome driver. And by the way, the IDE is called PyCharm and it's recommended by Google. And if you wanna like get your TensorFlow certificate, you need to use this IDE. It's like Anaconda. You have Jupyter Notebook and you have Spider. This is more likely like Spider, and it's been like 2 days for me now using it. So like you said, like you are saying, I'm trying to acquire new skills and use new technologies with you. So what you're gonna do is file new project, like the routine thing in programming, and you make sure you have a virtual environment and you have a base interpreter. And then you're gonna name your projects and you're gonna have a folder like this. I know it's like a kind of too fast, but like it's are the basics, and this is like intermediate to advanced level. So, and by the way, because I have met you in the bootcamp a couple of months ago, you guys are kind of special because I go to engineering universities, and you guys like have more energy to do IT stuff. So I think you can follow. And by the way, since this is going to be a record, you can go back to the live and check whatever thing you did not understand. And by the way, you can always send me an invitation on LinkedIn and maybe on Facebook if you prefer Facebook. And I can answer the questions related to tonight's workshop. And if you need some help with some of your projects, I may like can contribute to something. So this is my official LinkedIn account. I'm gonna leave it in the message. And can you share the notebook? Of course, Hamdi, I'm gonna share everything. And by the way, this is only for academical purposes because it's not entirely ethical to scrape data from other websites, because if you go to those websites, this allows scraping the data. So this is just for academical purposes. So, and here we are. We're gonna start by creating a file. It's called scrape function, and this is the function that's gonna gather Tunisia stock values. So we're gonna go to the website elborsa.com, and we're gonna, instead of me like being like this, doing something manual, we the IT people hate that. We hate like mundane tasks, so we usually make some code to make this automatic, and then you're gonna look for Tunisia stock, and then you're gonna download it and stuff like that. So if you're gonna do this process hundreds of times, it's really time consuming and it's really stupid. So we need the code to automate this process. I'm gonna show you what a human being will do. It's like we write El Borsa, we get El Borsa, then we go to les cotations. It's French, sorry. Then we go to Tunisia, and then we go to télécharger les cotations. Et puis, on va choisir l'intervalle. We're going to choose the range of dates which that we need to use in our model to predict the future. So, surprise, surprise, I have chose the last 5 years, which is kind of a lot of data, but it's not a lot of data. So in order to use artificial neural networks efficiently, we need thousands and thousands and sometimes millions of data points to make an accurate model. So when I scraped 2020 and 2021, it was like 300 data points, and that's and that's like very, very few kind of data. So then I was like, okay, let's scrape 5 years worth of data. So we need to click a lot. Like we're gonna spend 5 minutes just clicking here and there, trying to not forget any data points. And like you can see, this is not efficient. So now I'm gonna have my own program that can do this kind of thing for me. Which, by the way, take like 1 day or 2 days of developing. So in Script function, I'm gonna import pandas, and which is like a Python library for tabular data manipulation, and then I'm gonna import time, import sleep. Why? Because I need to behave like a human being on the website. Otherwise, they're gonna detect I'm a robot. And once they detect I'm a robot, they're gonna ban my IP address. And once they ban my IP address, obviously I cannot access the website. Well, I doubt elbursa.com can do that, and good luck if they can. And please do not call the cops. This is kind of fishy. And then we're gonna import Selenium as the web driver I told you about. It's in here. I already extracted it. And then we're gonna use Selenium web driver common action chains. So we're gonna have a chain of action. Do this, do that, do this and that, and if this does not work, do that, and if that does not work, do this. We import that and then we define our function. I only need two informations: the year I want to scrap and the ticker. And what is a ticker? So on the stock market, in stock exchange listed companies, every company has a name. Like for example, Apple, it's AAPL. Tesla is TSLA, I think. And Tunisia is TAIR. So I open my Chrome driver and I tell him to go to elbursa.com, elbursa.com, and then I look for TTAIR, Tunisia. And then I sleep. Why? Because when you open the website does not open in 1 second. You need to wait for the whole website components to load. Because if you go to another command and the website is not fully loaded, they will not find the element. Like I think you have done some web development and you know what is an ID, a class, a div, a paragraph. So those elements, you need to wait for them to load. And then I'm gonna start manipulating the, it's not a form, but I'm gonna start to manipulate the date range. So I download what I think it's what I want. And it's gonna start from 2017, then 2018, then 2019, then 2020. The glorious year at staying at home and doing everything at home, and then 2021, another glorious year. But
excuse me, you cannot download more than 3 months.
Oh, I love you, Ihab, already. I'm a programmer, so I anticipate this. What I did is like every time I only download 3 months, and then I increment my variable, so it automatically goes to the next month. And I do this for 5 years worth of data. So each year we have 4 files to download, and you multiply them by 4 is 16 file. And in 2021 we have two trimesters, 2 quarters. So in total we're gonna have 18 files. Thank you for the question, Ihab. And then we're gonna perform all these tasks. These tasks will click like physically and go. I think you guys will be so interested in scraping the data more than the TensorFlow model. And please do not do this at home. Like honestly, if they detect you, and I know in Tunisia they don't do that, you're gonna have a lot of, I will not say a lot of issues, but be careful. And like I always say, this is only for academical purposes. We only are trying to advance science. Anyway, where am I? Oh, so every time I'm gonna click and click again and again and again and again. And the interesting thing, sometimes the structure is changing, so I need to anticipate that. And sometimes you click and then you download and it's wrong. So you need to try. Like, guys, always take a deep breath and try. So the same action, I'm repeating it 4 times. Why? Because sometimes it detects that I'm a robot and does not give me the result I want. So I need to act stupid like humans, and I need to sleep a little bit every time. So he thinks I'm a human. And then I was like, gotcha, I did it. First time I done it on El Bursa website, it took me like 5 hours. And then I discovered that the web developer that designed the website is not that bright. And here we go. Now the main file is not that file. So in Tunisia Stock Exchange, the glorious stock exchange that other countries are very jealous of, we have around 55 companies. That's ginormous. I know. It's like Wall Street. We're gonna only be interested in Tunisia, so I commented this, and then I call the function, which is another Python file. So the glorious thing about PyCharm is like you can code in separate files. If you have a Jupyter notebook, you cannot do this. You cannot create a file, then create a function, then call it inside another file, because you need a lot of other source code to make the different Jupyter notebooks connect with each other. But when you code just a Python file, you can call it in another file, and your work look great.
Actually, a text editor will make the F here.
Yeah, you can do it in a text editor, but IDE is better for programming because it gives you your mistakes and gives you a lot of things that we're gonna see with each other, like creating a virtual environment, creating separate projects, debugging, and you can see your whole structures of files, and then you can see even inside the variables. And I started using PyCharm yesterday. So every time I challenge myself in doing a live workshop, and last night I was having nightmares. I was like, please do not embarrass yourself. you should rehearse it more. And I spent the whole night. I was like, damn. It was a bad night. So today I stayed at home the whole day trying not to embarrass myself. Which, if I was a finance guy, I would be like in a suit and talking eloquently how smart I am, but I'm not. Anyway, so this is the main file. I'm gonna give it the number of years to scrape. And by the way, if the code is correct, it's gonna exit with 0 code. So and by the way, this is the glorious thing about PyCharm. I'm not doing a publicity for it because obviously I'm not getting paid. And like you can run the whole file, run script.
Or part of the script, yeah.
Yeah, or part of the script. It's like a spider. And process finish it with an exit code of 0, which means there is no mistakes. But if you have a code different than 0, you have a mistake. And in this file, we're going to have an exit code of 1. And we're gonna see the mistake together, and I'm gonna show you how to correct it. And guys, let me see how many survivors. We started with 33. Okay, 29. Hopefully it does not go below 20. Okay, so for the survivors, this is only getting more complicated. Good news. So these are the years we're going to scrape, and it's Tunisia in here. Then this will call this file and execute whatever you have in here. After that, since we're going to have a lot of files, the stupid thing is to go inside every file and copy all of the data and paste it 18 times. And believe me, you have engineers that do that, which is like, okay, let's change the subject. And then we're gonna join all that data in one file, and we're gonna visualize if that happens. And if this is your first time scraping the data, you're gonna have a lot of fun. By the way, let's see who's here. Nice. I always love this. Every time I do it, I think to myself, this is magical, like a small boy. And I'm pressing on Shift and Enter because I'm used to the notebooks, but in here, you do not do that. You run the file. Allow access. And I'm not touching anything. My hand's in the air, and now I'm realizing that the cam is closed, and my hand's in the air. I swear to you guys, I'm not touching anything. It's doing all of this by itself. Stupidly, I'm putting my hands in the air. And you see, like in here, the period, the dates are changing, and you see how fast it is. No human can like type that fast. And it downloads the second file. Okay, why is starting from 18? I think I know why I start from 18. Okay, exit. I exited the code because I did not delete the old files. Okay, the old files are in here. Let's delete them. I want to open the cam so I show you my hands are in the air, but I'm afraid my mobile plan will expire. So please believe me. Let's do it again. نزلت ببص على shift entry. This is PyCharm. We use Control Shift F10. Okay. And the magic. Now we're gonna scrape the data starting from 2017 until 2021. Why start from 20? That's so weird. I should not start from 20. Damn, I think I deleted the wrong. I deleted the wrong directory. Exit. Okay. أعزائي المشاهدين هذه ظروف المباشر. Okay, now I'm sure it's empty. Yeah, it's empty. Where am I? I'm here. Please do it right. Please do it right. So we are seeing that the directory is empty, and it's going to be filled right now. Yes, it's working. It's been 3 years doing this stuff, and I still think it's like cool. So the first 4 files are from 2017, and because we have 4 quarters, then we're gonna have 4 files. And now we're gonna go to the year 2018. This is a very boring job for humans to do. So we have automated this process. By the way, maybe I open the cam and show you. Here I am. Okay, so this is the cam opened, and this is it's working by itself. I feel like Chris Angel. Okay, it's downloading, keeping the same job. Yeah, maybe Houdini. Chris Angel is not that cool. Or maybe I like David Blaine. I think I need to send this to David Blaine. Or maybe I will go to Joe Rogan podcast and talk about the simplest technology on earth. And now it's time to shut down my cam. Okay. We can make this process even more faster, but we always I always worry about them catching me and blocking my access. Actually, I'm not even worried because they are Tunisian websites, so who cares? And this is what happens in real life when you are working on a project. The simplest thing is to do, it's like the modeling part is only 10%. The modeling part that we're going to do tonight is only 10%. And I chose an advanced model that I have used in a competition, which is like $100,000 for the winners, which obviously I was not. Otherwise, I would be like in Monaco or I don't know. So I'm still here with you. And we are waiting in the run part so we can see the error at the end. The person who tells me, oh, now we have the error. Then we go back in here and we see, oh, you guys did not see it. Okay, I'm going to do it manually. Pas de données disponibles pour les dates choisies. Fermez cette fenêtre. Donc, c'était ça. And this is telling us that the program did not scrape the whole 2021, the whole data year, because we are still in June. And in my program, I kept incrementing the months, and then it stopped by itself. So in here, the exit code, I can control it with a try catch block. But like I said, I started doing this yesterday.
Or with a break, I think. You can use the break command.
Yeah, exactly. And like we can exit with a code and another message, a more customized message. I had a hectic week, so I only started yesterday. So this is not real live coding, but it's like 2 hours ago coding. I think that counts, at least a little bit. Anyway, then let's go and see our data. Well, okay, can you be a little bit bigger? Okay, nice. This is 2017 until 2021, and we have 18 quarters. So in finance industry, they measure everything in quarters. Like every 3 months, company assess their profit and losses, and they make decisions every quarter. It's very reasonable for El Bursa. By the way, funny fact about El Bursa, it was implemented by a student, and when before even graduation, he was making 2,000 dinar, I think, a week or maybe a month, and he was a student. And his friend, he was my roommate, and at that time, my roommate was brilliant in mathematics, and he told me, "Hey MK, why you did not code in your Bitcoin?" And I was like, "Bro, I do not have time for that." uh,
شوية
that
هو
was
مشى
like
لموناكو وانت قاطعهم في اللايف.
exactly like really funny how lives goes. At that time, I was studying math and physics, the most boring things that you can do in your life. And he knows that I code all the time. I code just for fun because I'm not that wise. And he was like, Bitcoin worth $200. Yeah. Let's see how Bitcoin is worth today. Bitcoin 98 مليون يا ابو قلب.
كان أكثر، كان 150 في بالي.
Yeah, but he crashed because Elon Musk cannot keep his mouth shut. Can you give that guy a cookie? Maybe if he starts eating, he stops talking. So my roommate was like, he was saying Il Bursa website. He was his friend, and he was like, okay, I can put you in contact and you can do some analytics things. At that time, I did not even know what machine learning is, but I just know how to code. And he was like, he wanted to do his own project. So he was like, MK, can you code cryptocurrency for us? And it was written, the source code of Bitcoin, which is like on GitHub. GitHub Bitcoin, and it was written in C++, and I was using C, and they are really different. So I told them I'm gonna learn C++, and by the time I have learned C++, Bitcoin was worth $400. And I was telling him about how we're gonna monetize this thing, and he did not have clear ideas. So I told him, okay, I'm gonna do something else. And then I started doing robotics. I was creating robots competing, wasting all my money, and feeling not wise. But like, this is part of the finance. And why I'm bringing this subject is mainly because I like to bring random subjects. And the thing is, like, we can predict Bitcoin value like we're gonna do with Tunisia tonight. So this data, we're gonna like go inside each file and copy paste. And copy paste it 18 times until we have blood on our fingers and put it in one file.
Yeah.
So 2017 and until 2021.
If I do remember, there is a merge command in pandas, موافق.
I did not understand what you're saying.
I said that I think that we have the merge command that exists in pandas.
You mean the code for that?
Yeah, I'm talking about the code, yeah.
Yeah, that was my surprise. Why you did ruin my surprise? Well, we were going to copy paste like the data until we get blood on our fingers. And like you ruined the party for us. So obviously, guys, we will not do that. And I developed a small code that can merge all the files, and we're going to execute it. In Jupyter Notebook, you cannot like you do not have the flexibility. Like you have different cells. In here, you just select what you want to execute. And execute. Okay, so the file should be what? ظروف المباشر. So a clever engineer is gonna spot that there is a different kind of format to the names. So you're gonna cheat a little bit, just a little bit, from 0 to 17. Okay, let's do again. I need to consider doing a YouTube channel where I have like 10 views. Okay, hopefully we created the file. Now we're gonna check if the file was created. And boom, life is good. Yeah, life is good when the code works, but when it does not work, like you have some kind of suicidal thoughts. And we have data that started in 2017 and it ends in 2021. And in here, I only told the program to visualize only 1,000 rows. So, ladies and gentlemen, we have finished, at least for me, the most interesting part, how to collect your data. Now we're gonna see the file that we have created. And like it gives you the freedom, you are not dependent on anyone. You have your own data. Okay, Tunisia, 2017, the volume of traded stocks is 4,600. It's almost to nothing. It's not that big. But in here it's 19,000. Damn, that's too much. Too much for the Tunisian stock market.
How can you decide that it is too much or not enough?
My dear, you do not decide. You only have intuition or feelings. Deciding is really not that.
Yeah, so no, because you already decided that it is not enough. So I think that you have...
Because we have a big jump, like from 4,000 to only 1,000 to 19,000. So it's really subjective to what you are seeing. And then because I should keep my mouth shut.
We should plot it, I think, the volume to...
Yeah, you can plot it, but it will not give us... but we are not doing analytics. We will try to make the machine learning model figure out it by itself.
Okay.
I almost said himself. Imagine the robots, we refer to them by he and she, and then it's going to be very interesting. So in the stock data, they usually tell you we only care about the opening, the high. This is the highest value during the day, the lowest value during the day. The most interesting thing is the value.
Price. The close price.
Exactly. I was going to translate it in a very.
But actually, Muwaffaq, actually, what we should take is the adjusted closed price, because we in that case we are going to take into account the splits and the dividends.
Yeah, but El Bursa does not give you
that. Yeah, I know. So in our case, we're just going to take the closed price.
This is Ihab's voice?
Yeah.
Okay, so I'm gonna show you guys some magic. So in 2020, I was competing in the competition with $100,000, and that competition have ended in 2021, and the result is gonna be announced next month. So. Oh no, I'm already losing. So we have 4,245 team. My best rank was, not to brag, but my best rank was 97 with the world's most interesting people. But my model has crashed. So if you want to see a real life kind of data for professional setting, you're gonna find over 130 features.
Exactly.
It's like almost 6 gigabytes of data, and then you're gonna have your adjusted closing price, and you're gonna have features that you will not even begin to understand, and the rumor is nobody does. So we are keeping it simple, and even in data camp course, And on Coursera courses, they only use these four variables. So in here, we are trying to predict the closing price. Someone is trying to break his home. Anyway, so we're trying to predict the closing price. So this is our target. But as you can see, the target is not at the end. We need to change things a little bit. How many survivors?
28.
20. Excellent. Only one of them have died, and hopefully his internet connection. I'm really surprised my internet connection did not make me look a fool. Okay, please keep working, please. And this is topnet is like the worst thing on earth. Anyway, so in this competition, if you want to see real life things, go check it. And if you want to be an expert on this, you will spend like at least 1 year studying this competition, at least.
Just one question, Muafaq. In that competition, what are you using as a model?
I started with XGBoost, then I created Cat Boost, which gave me some repetition. And then I have used TensorFlow. I was trying to use CNN, but CNN is computationally heavy. So my notebooks were expiring all the time. I have submitted like 70 model. And some people have reached more than 200 submissions, but they are working in teams. And by the way, Ramash, which is a Google Cloud Services consultant, and he's the guy that made the trading course on Coursera. He was in the competition, and we have giants like Two Sigma, if you know Two Sigma.
Yeah.
And like the other, like the guys that kind of make me a little bit concerned, like from Vanguard, BlackRock, those goddamn people was competing too. It was like anyway, but like you learn a lot. Like it's really worth it. Now let's go back to our humble doings. Workshop, where the hell am I? I'm here. So I was trying to use PyCharm, but my internet connection has shut down, so I couldn't download TensorFlow. So I'm gonna be using Colab. So here in Google Colab, we're gonna try to do the same job. Not do the same job, like implement our what?
Are you going to build an LSTM model?
No, because I'm gonna build a model that does not even have a name, but it really have good results.
Okay.
But do not try this in a professional setting. Do not. I will not say replicate it. You can use it wherever you want, but it will not give you like great results. It's just something that I have learned, and I know it works. Why I will not use LSTM? Because even LSTM is computationally heavy. It takes a lot of time to execute. Bidirectional LSTM is the same. I will recommend using GRU, and they are less computationally heavy and with better results. I had another idea as like coding the whole night because obviously I have nothing else to do. But I remember this is not a YouTube channel, so I'm gonna keep it like I'm gonna code for another half an hour, and then we're gonna have a funny Kahoot, which is easy just to encourage people to have a good time. This is not a punishment. This is learning. So let's deep dive. We're gonna start by import pandas as PD, then import NumPy as NP, and then from sklearn, we're gonna import the model selection, and then we're gonna import train, test, and split.
There is just an additional I in your import train test split. In the import, no, this is, this in the import command.
In import train test split.
Yeah.
Oh, thank you.
Yeah.
Most of welcome.
So TensorFlow as TF, and then we're gonna run. By the way, tonight's model is not really adjusted for the data. So tonight's model is a copy-paste from my original work on Jane Street competition on Kaggle. So do not take it that seriously, but I wanted to show you something a little bit advanced. And sometimes like people surprise you, like big engineering schools, they still want to have introductory level workshops. Unlike other schools, they want something intermediate and advanced, which makes me happy. And then from where I'm gonna get my data. So my data is in here. And I don't want to upload it. So what I'm going to do is like host it on GitHub. Tunisia stack scraping predicting. So this is the notebook. I'm going to share it with you guys. Oh, it's a typo on the first one. And then I'm gonna transfer the data from GitHub to Google Colab, and this is a very cool thing. Copy, and boom. Then I'm gonna give my data the column names, which is column names. By the way, I've been coding for 16 years, and I'm not even a fast typer. Symbol, et puis on a date, et puis on a ouverture, et puis on a O, now O, et puis on a bas, now clôture, volume, not again. And those are the colors we're going to use. And then I'm going to now import my data using pandas, read CSV. Yeah, read CSV. Because the format is CSV, I'm going to give it the URL and then the names, which is column. What is the shortcut? Give me the column. Oh, now you give it. Fuck you. And separator. The separator, so when you have a CSV file, the data is separated by semicolon. And then this is the mistake that made me waste a lot of time, which is the header. Now, the header was imported twice. So we need to specify that the first row is the header, and then even inside the data, when you have like 10.7, the separator, the decimal separator is a comma. You need to specify that, otherwise your data is going to be wrongly imported, and this is very time consuming. I'm talking sometimes it takes hours to, when you implement the model, you think the model is wrong, you think maybe the data processing is wrong, but actually sometimes importing the data is wrong. Read CSV got an expected key argument name. Okay, so how
call names, Belekshi, call names, I think.
Column like names.
Call names, I think. That just I'm going to call names, right? Call names.
Name. What is that? Names. Oh, okay. Good. We have 1,056 rows and 7 columns. Great. So we have the symbol, the date, the l'ouverture or by closure volume. Donc, we are good. It's identical to this file. Goodbye, Mr. File.
Use calls, plutôt.
Okay, now what we're gonna do is the data processing. And by the way, we do not have missing values, so good for us. But I want to predict the last feature, which is the column. So I need to put the clôture à la place de volume. Donc, ce qu'on va faire, c'est on va copier ça et coller. It's getting really hot.
You can just type target equal to, I don't know how you call the data. For example, data clôture and features data dot call names different of the target, and you get the features.
Yeah, by the time you finish your idea orally, I will be finishing typing it. Okay. What did you say?
It's okay.
I'm faster. So we have the clôture à la fin. This will make our job really easy. And what we're gonna do right now is take the data. I'm gonna show you something I did when I was a student. On avait cette dataset avec des data pour savoir si l'accouchement va être prématuré ou non. So, it's a very famous dataset. Why you are being sexist? This is a sexist laugh from a guy. To all feminists in the world, right now I'm defending you, at least right now. So, okay, we still have 27 survivors. Okay, amazing, guys. So, what you are seeing in pink, because I like the color pink, is the data that I'm gonna train to create my model.
Yeah. Sorry for cutting you off. Sorry. Could you please keep an eye on the chat because there are participants that are asking questions. So just make sure.
Just tell me why the target should be the last. No, it does not should be the last one, but it's more convenient. And I'm gonna show you why it's more convenient. So,
okay.
So this.
I'll let you know when there is a question in the comments.
Okay, awesome. Thank you, Taha.
Yeah, sure. You're welcome.
So I want to predict this feature, the premature feature. It's the last one, you see? So I'm gonna train my whole data on the pink data, which is the training data, and I'm gonna tell them if you have gesture, delayed, sans en français, membrane, age, age or age, strat. Anyway, these features, if I have these kind of values, it's a positive. So the lady in here is going to have a premature, I don't know the word. But in other kind of situations, when we have these kind of data, is going to be negative. She will not have a premature accouchement or premature. No, not that one. Then go back. So I'm gonna divide my data into 4 parts. I'm gonna tell my model, if you have this kind of data, you have this kind of result. So the model is gonna memorize, then generalize this data, and he's gonna know this. But then the prediction is gonna be on unseen data. So in yellow in here, this is the data that the model will not see. And the objective is the Y test, the Y test. We will try, after training our model on the pink and green data, we're gonna give him the yellow data, and the whole objective is to predict the data in black. So it's really easy for me to put the target feature at the end of the data frame. But it's not mandatory. It's every programmer has his own cup of tea.
It's for convenience, actually.
Convenience, exactly. sometimes I lack finding the exact word. So, and because it's convenient, let me show you how fast I can do this. It's and then we're gonna
I
use
look. There is a U, another U. You should delete it. Yeah.
yeah. Thank you. And then we're gonna convert our data so it can be floats because that kind of data I think that it's from type object and string, and for TensorFlow to run it needs to be floats, and then we're gonna convert it from pandas to NumPy, and then we're gonna visualize our data. This is X, and boom. So what I did is I took ouverture or by volume et clôture.
Yep.
And then I'm gonna specify the Y field, the target field. I'm gonna tell him the target is gonna be data.clôture, and I'm gonna convert it to NumPy by making Y bound values, and boom. So from this data, I need to predict this data, but I'm going to train my model first on the data I have. So let's split it. X-train is the data without the target. X-test. Oh no, X-train is the. I'm going to show it to you. So this is in the pink one, it's X-train. And the yellow one is the X-test. So you have like a visual kind of representation. And then we're going to have Y-train and them. Y-train and Y-test, which are these. Y-train and Y-test. And we're going to split the initial data with train, test, and split. X, Y, and the test size. This is the data that I'm going to use for test. Is going to be only 20% on the original data set. So the X-train X-test is going to have 80% of this data, and Y-train and Y-test is going to have only 20% of this data. The random state is to replicate the same result. So if all of us, we put the same random state number, we're going to have almost the same result. If we
excuse me, Muwafaq, to interrupt you. Actually, if we fix the random state as the same number like you did, we will get all the same result. Also, I think that you should add shuffle to.
Oh, I cannot hear you. Still can't hear you.
Like that, are you listening to me?
Yeah.
Okay. So I said that I think that you should add an additional command in the train test split function, which is shuffle fixed to false, because with time series data we don't have to do cross validation.
Yeah, it's an idea. It's a good idea. Except that
we have to fix it actually, because the time series we should respect the sequence of the data.
Yeah, that's why I kept the date out of the equation. I'm going to show you something that you did not consider. So when we split the data in here, we put it from 2 to 6. 0, 1, 2, 3, 4, 5, 6. So I have skipped the date. Why?
Yeah, Even if you skip the date, the order remains the same.
So when I skip the date, there is nothing in the rest of the data that tells my model this is a time series. Okay? Why I did that? I want to test the model without the date, without the time series itself. And then the second model you guys gonna implement by yourself if you want to, is to add the date in here, which is very simple. Just change the two with one. Why I'm doing this? Because sometimes the models, the machine learning models, can detect the time series by themselves. You did not explicitly say that. And
no, but even if you delete the date column, actually it is respecting the structure of the original data. It is like it is even without the date column.
yeah, so you want to shuffle the data.
Actually, I don't want to shuffle the data because it shouldn't be shuffled the data.
Yeah, then what's the problem?
I just said that I think that we should add an additional comment in the train test split, which is shuffle fixed to false. That's it.
Oh, I think it's by default fixed to false.
I think also, but I'm not sure. This is why I said that.
No, it's by default fixed to false. I'm gonna
Okay.
say.
Okay.
No, it does not shuffle by itself. See, next shuffle split is.
Shuffle true. It is by default true, so we should fix it as at false.
Oh, damn.
Mm.
Whether or not to shuffle the data before splitting. If shuffle false, then certify must be none. Boolean.
None. We should put none, not false. Actually, none. Yeah. Ah, false. No, false. Yeah, we should fix it as false. Yeah, false. Mm.
Default is true.
It should be false. Exactly. Yeah, we should add this argument actually.
Okay. I don't know why I thought it's always the default is false. Okay, thank you so much for the clarification.
You're welcome.
Yeah, I thought it's by default is false.
No problem. It's okay.
Okay, so what I usually do is I do not even use the train test split. I do it by myself. I'm gonna show you. Kaggle simple MLP. I thought it's gonna be easy using train test split, but this is what I use. So this is the data I have. And what I do is I split the data based on the names. If they have feature in them, I put them in train. And these are my targets, which are 4 targets. And then this is how I split it. Train log, I take whatever I want. And then I put another condition. So in here, when I use the train test, I automatically fit it without using train test split.
Yeah.
Because I have more control over my testing. But thank you so much for clarifying that. It's been a while since I have used it. So I think this is very useful.
You're welcome.
Now we're gonna proceed and we're gonna have a better result, obviously. Where is the code? So let's try to execute this. So in the X train, which is this one, we're gonna have more than 800 data points. And X train, X test. That's Y train and Y test. Test. We're gonna see how we have split our data. So we're gonna train it on 844 data points, and we have here the number of features. And we're gonna test it on y-test, which is like 200 data points. And 1,000 data points is really, really almost to nothing. So when we have a neural network and you feed it like 1,000 data points, that's nothing. Why in real life, we do not have only 4 features. We have dozens of features, maybe hundreds. It depends on the company that you work for, which kind of data they have access to, and that will be very helpful. So because there are 100, around 1,000 data points, we can use even simpler models like linear regression or just a decision tree. But the point in here is to use an artificial neural network to have some grasp on it. I would love to use this 5 gigabytes of data, but it's gonna take a lot of explanation to go through the source code. But it's,
excuse me once again.
Yeah.
I think that we should normalize the volume actually to put it in the same scale as the other features.
What I usually do not do is scaling the data. You have the first model, you need to put some kind of raw data. So it works like a benchmark, a baseline.
I would like to use a baseline. Okay. Okay.
Yeah.
But
so,
but usually in the stock market, in modeling, in finance modeling, what we do is to use the index as our baseline, for example.
What do you mean by index?
For example, to calculate the earnings, we use the Tune index earnings as a benchmark. But in our case here, I think that
I'm benchmarking the models.
Yeah, but how are you going to benchmark the models? By using all the features?
So what I'm gonna do is like try to have some data processing like this one and this one, changing the types, and then just feed them the model as they are. You see, that's why I was not really concerned about train test split. I want to see it. I want to see the result, and then the next model, what I'm gonna do is like change small things one time each time. So I know how my model reacts to it. And by the way, like normalizing the data is not always the good solution. Because if you have the volume in here and you normalize it, it's gonna be, for example, the 4,600 is gonna be 0.4, I guess, because we have 40,000, maybe 0.2.
You normalize all the features in the same time.
Yeah, it really messes the structure of the data, because in here if you have the 4,000, you know that you have a bigger volume. You see?
Yeah, but I mean, when you are going to feed your neural network, your data should be normalized.
Not always. No, not always. Especially in the baseline. Because if in the baseline you normalize the data and you do all the data processing ideas that you have in your mind, then you will not know which kind of option that you did that have improved your result. Do you understand what I'm saying?
Okay, I'm going to follow your idea.
It's not following my idea. It's like if you put all the ideas in the first model, then you will not even know which one and which not does not work. And when like you do one hot encoding, like for encoding your data, or you scale the informations, you can lose the ordinality of the data, and you can lose the weights of the data because if in here is going to be 0 point something, that will not really reflect the importance of the volume. Actually, when you normalize it, like almost all the features will have similar weights, which I really do not recommend.
What we usually do is to scale the data, then there is a function, for example, which is min max scaler in sklearn.
There are 9 functions to scale the data,
Yeah,
and in the baseline, I never use them.
You can for example, scale it and then rescale it back to normal.
In the baseline, I never use them, and like on like in the following codes, I try to add one idea at a time. This is why you are failing to understand. Like if you go to a competition, you scale the data, you normalize the data, you do the one hot encoding, you feed forward the missing values, and then you have only one model that you can never change because you do not know how your model have evolved between each idea you have implemented. Am I clear?
Yes.
No, I think he's not convinced. Let me tell you something. Go to competition and put all the code that you know, all the things that you have heard. Put the min max, even the min max in here will not be that great, and scale the data as you like. And then after you have your first model, tell me how you're going to improve it.
Actually, I personally don't use the volume feature as a feature, for example, to predict. But I will have a look to your catalog. To your target. Okay.
Let me show you something. This is one competition, only one competition. Can we count the notebooks? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Thousands, mashallah.
10, 11, 12, 13. Now you're gonna bear with me. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 20, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 30, 10, 30, 10, 40, 41, 42. And you like every time I change one small thing, my dear friend, because if you jump to putting all the things that you have heard, actually you copy paste all the things that you have heard, then you will be having only 1 or 2 models and you will not know how to start to adjust them. These are the best practices. I know in the workshops how people do it. They bring their fancy terms and then they put all of them into one notebook. What I have saw in the physical competitions, like people in 24 or 48 hours together in one room, after 2 to 3 hours, everybody is out because they have done all their fancy tricks at once. It's like, imagine you are taking a medicine. You only take 1 pill a day. You do not take the whole tablet the same day. So you have a room for change. You have a room for feedback. Like in here, like dropping the date, which is like a very small thing. And even here, like shuffling, which was gonna be wrong. But if I'm gonna have wrong results, I'm gonna try to suspect each and every one. And after that, I'm gonna change the model a little bit, like tweaking at each time, so I know which one is gonna work. Now, let's say you have 5 cool tricks, and like you said, it's mandatory. But if it's mandatory, show me the research paper. And those like mandatory things that you said you need to do, you put them the five of them at the same time. Now let's assume one of those 5 is not working. How are you going to determine that? And now let's assume one of those 5 is outperforming all of those 4 tricks. How are you going to determine that? This is like A/B testing. Each time you tweak the model a little bit. And this is how some competitors have put like more than 200 models. This is like the final results, not the final, but now the competition has closed. You cannot see the number of submissions. The people that jump to put all the tricks together, they will not know which one to proceed with. And like I said, in here, the data processing will stay missing a lot of things. But if you want to see something complete, I would just advise you to go here. Where on earth? No, not that one. No. Your repositories, market. This one. Okay. This is my work and research. And in here, you can feel free to check all the tricks about processing the data.
Can you copy paste, please, Muafaq?
What?
Can you copy paste the link, please?
Yeah, of course. Do you start the notebooks from scratch?
Thanks.
No, Hamza, I usually do not start from scratch because there are brilliant notebooks out there. It's better to understand them and to add some value to them. And sometimes I start them from scratch, like I'm going to show you right now. This took me a long time because I had a specific idea in my mind, like nobody has done it, and I want to spend my time doing it, which is called Cat Boost for Dummies. And this is the version 7. I even have other versions. I'm gonna share it with you too. And in here, I started from scratch. But sometimes you find other people with other ideas, and you want to improve on those ideas so you gain time, especially in competitions. I think that's good for Hamza. And Ihab, do you still have other concerns?
Sorry, Muafaq?
Do you still have other concerns?
No concerns for now.
Okay, for now. So Ihab, for the full data processing, just go to the first link I have shared, which is market prediction building trading strategies.
Okay.
Please check the notebooks in there. There are a lot of tricks about data processing, and I did not even use normalization.
Okay.
I think it kills the data value differences. Like everybody, all the data points are the same or close or something. Like I want them to be different. This is something I convinced by, but like other people, yeah, they normalize them from the beginning.
Okay.
Okay. TBS people have more in-depth engineering discussion than the engineering people. What a weird word. Okay. Now I'm going to implement the model. And believe me, it has some good results, but even I don't really understand everything about it. So to be completely honest, I'm going to show you a lot of weird stuff. You see the seed number is 1111, and mysteriously those numbers are random, and that random number is better than most. Nobody knows why. It's just the random aspect of the models, since they are black boxes. If you put the seed for ones, you're gonna outperform other models, even if other people's models are better than yours. You will not find that in a research paper, but the explanation is the randomosity of the models. Okay, that's a long line. which I have copied from the notebooks I have shared with you earlier. And let's start with coding the TensorFlow model. So this is the input, and the input I'm going to give it TensorFlow, Keras, and we always use Keras because it's the higher level API, and layers, and I'm going to have my input layer. The input layer needs to have the shape, and the shape is based on the number of columns. And by the way, like the result of this notebook, do not take it for serious, because it has a lot of issues like to go over before considering it. I'm going to show you why it's a bad notebook. And you're going to wonder why he's sharing with us about notebook, because if I'm going to share with you something good, most likely you will not be curious to make it better. But please try to make it better and share your results with me. Okay, input. So this is the first layer, and the shape of the first layer is the number of columns, which are 4. And then the layers, we have batch normalization. Now we are talking about the normalization. So you see the data that we had in here. We kind of batch normalize them. So we divide them into small groups, and we normalize them, but in not a very specific manner, because we did not like say which kind of normalization actually we are doing inside. Layers, dropout, drop. So what is a dropout? Inside the layer, so the neural networks have many layers, and in every layer there are many neurons. So for the layers not to memorize what they are seeing, every time we randomly drop a couple of neurons, which means the dropout rates. So we randomly, so if we know if a student is smart or not smart, we're gonna tell him, hey, instead of assisting every time to the same course, we're gonna make you, so if you have 10 courses, we're gonna make you assist only 9 times. A smart student will generalize from the 9 times, but if he goes 10 times over there, he may be memorizing, not learning. And this is what we exactly do with neural networks. We prevent them from memorizing, because the educational system, they do not give us creativity. They do not give us enough space to be creative. They give us a lot of informations. The smart thing is, do not give us a lot of informations. Give us just the right amount. And
dropout prevents overfitting. This is the idea behind it.
And overfitting comes from memorization. So that's the difference between a good student and a bad student.
Yeah.
A good student will try to generalize from minimal kind of information, and a bad student, he will try to be always present so he can memorize what the professor is saying. And I think we all run into that kind of thing. So these are the dense layers, and these are the dense layers that we have them in our brains, and these are the ones that are thinking. We will try to mimic our brain behavior. This is like very, very basic, but we can build on top of it. Now we have the activation function. What the activation function is going to do is so we have the layers. Inside the layers, we have many neurons. And when we put the data inside of those neurons, not all the nodes is gonna fire it up and give us a result. We need an activation function that says, hey, if you reach 5, you can go through. If you reach 3, you are out. If you reach 10, maybe that's kind of overfitting. So you try to activate the neurons inside your layers, and you have different mathematical equations. So we're going to use Keras activations switch. And we're going to put an X. Now, the dropout, the last one is drop out. I'm starting to get a little bit tired. Dropout rates. Yeah, dropout rates. Okay, hopefully I did not make any mistakes in this code. Otherwise, it's going to be really painful to correct. So, TF Keras layers input, shape, num columns, layers batch normalization input, Keras layers dropout rates, and then we're going to iterate on top of each hidden unit. So each time we're gonna do this for processes, so we can get our final layer before the output. So TF Keras. Yeah, I think you are right now bored. This is like programming. This is like not a very fancy thing.
Yeah, actually, Keras is more simpler than TensorFlow.
Yeah, if you're gonna code in TensorFlow, it's gonna be even more boring and more difficult. But it's gonna be shitstorm if I made a mistake. It's really hard to correct the mistakes in sigmoid. So the activation function that is gonna give us the final prediction is called sigmoid, and this mathematical function is really simple. The sigmoid is like a value between
minus 1 and 1, I think.
So sigmoid function,
yeah,
it's like you said, it's between a minus value and a positive value. It's going to give us a probability of the value of that stock.
But sigmoid function, it should be used for classification tasks.
Yeah, so we can alter it, like we can any classification.
Change we should maybe label
softmax.
No, softmax actually it's going to give the probabilities of the outputs. No, not softmax. The problem here is the target. We should label we should encode the target actually. I think that we should encode the target. One hot encoding. We have to do one.
No. I don't use one hot encoding. I don't. I almost never use one hot encoding.
Yeah, but I using.
Why you want to encode the data? Like you encode the data if it's not numerical, for example. And even one hot encoding, if you have a lot of features, you're going to have an exploding number of features at the end. You see, if you do one hot encoding, you're going to lose the ordinality of the values inside the code.
Yeah, but in the meantime, using sigmoid will not be the correct function to use.
Yeah, but most of classification problems And even if you put a classification algorithm inside of them, they can give you a regression, and vice versa. Those are kind of tricks. Like, let's take a decision tree classifier. You can change a decision tree classifier to decision tree regression, and vice versa.
Yeah, true. Yeah.
Yeah, I'm gonna wait for your suggestion instead of sigmoid.
But
First, I don't know what to use as function, but because from what I know, I'm not at all specialized on deep learning, but from what I know, there is sigmoid ReLU and leaky ReLU and softmax, as you said, I think.
Yeah.
That's it, right? Or there are more functions?
There are other variants.
Yeah.
But they do not differ a lot.
Exactly. So yeah.
Yeah, I'm just waiting for you open for your suggestion.
actually, usually what we do is to in deep learning, in finance deep learning, if you want, or in deep learning in the context of finance, we use LSTM or combine LSTM and CNN models, for example.
There are no rules about those, and like I said, we can keep talking till the morning, and you can go to Kaggle and see like the brightest people what they are using. If you are using the CNN that you keep talking about and the LSTM you're gonna keep talking about, they're gonna have a lot of time to train those models. And if you have a lot of time training those models, your model will not be profitable. And the winning model is based on XGBoost and some other layers, I think, in PyTorch. And they are not LSTM, and they are not CNN. And there is no sector basics. So you say in general in finance, you use this and that. No, there is no such a thing. And if you have such a thing, give me the research paper.
Muwaffaq, we do have some comments, so
okay.
If you don't mind, yeah.
If you don't use one-hot encoding for categorical features, what do you suggest? For example, you can use dummy encoding because it does not take. If you have one feature and with dummy encoding, you're gonna still have a very limited number of features. You can use the factorize. So if you have summer, winter, autumn, and spring, and you factorize them, you're gonna have 0, 1, 2, 3, and 4. But for one-hot encoding, if you have like 4 features, like 4 different values, you're gonna have many other newly created features, and all of them are 0, 1, 1, 0, 1, 1, and 0, 1, 1. So you lose the ordinality of the data. I'm gonna try to give you an example. So in a market, when a lot of variables are connected, for example, let's say in the tech market. In the tech market, if you have the semiconductor market where, for example, silicon-based circuits, they are in a different sector in finance, and you have these kind of features, and you want to one-hot encode them. There's going to be all of them between 0 and 1. You're going to lose the relationship between 2 different sectors. If you have one feature that correlates with the other feature, and you one-hot encode them, you're going to have a lot of other new features. And the aspect of the correlation between them, you're going to lose it. Some people keep on using it. They will tell you it's okay, keep on using it, but that's not the real thing. You destroy the relationship between the data points, at least from my perspective. And like I'm telling you, like this, those ready-to-go copy-paste codes, if you have a real-life problem, which can a little bit advanced, they will not give you a good result. And there are no rules and no standards. And that's what most of the research papers are saying. You cannot like, let's say, objectify differentiate. Because in the medical field, you have this. In the finance field, no. Most algorithms used in the finance field, they try and run like right now to ignore the time series aspect of the thing, and they keep the sequence aspect of it. So if somebody tells you do this and that exactly in that kind of sector, it's most probably wrong. Why I'm very certain and sure about these kind of things, because I read a lot of notebooks and calculus. Like people read books, I just amuse myself and read notebooks, and they make a lot of money, and they put their models into production. And many companies, like Two Sigma, they have done 3 different competitions on Kaggle. Do you think if the findings were wrong, they will keep on doing that? Of course not. So it's really subject to what you try, based on your trial and errors. Everything is subject to that. Now, there is another function, yeah, the 10H, tangent hyperbolique. Oui. There is tangent hyperbolique. We can use them. Other questions? Fast AI is even simpler. Yeah, Fast AI is even simpler, and it's based on Kaggle competitions. So they took all the aspects of things and they integrated to really compact codes that can do most of things. But I think I never used Fast AI. I actually used Fast AI, but it was not my source code. I just changed a little bit, some aspects of it. So I know, guys, you really get bored from coding this live. So I'm gonna try to accelerate. I'm gonna execute this. And in here, line 15. So we will try to go back and see in line 15, what do we have? So line 15. I think the view can give us show hide code, hide output, tools. Okay. 3, 4, 5, 6, 7, 8, 9. Oh, this one. TensorFlow, Keras layers, dense layers, norm labels. Norm labels. I will try to copy paste that one so we can skip it really fast. Okay, that's wrong. It's running. So what I have done, I have copy pasted the rest of the code, so we do not spend the whole night in here. And this is like, it's going to be the surprise. So this is the code I copy pasted. What we're going to do is what we're going to have is the number of columns, number of labels, the epochs, which are 10, and 10 is really few, but we can add them so you can see how the model is trying to learn by itself. But there is a mistake in here in the metrics accuracy. You're going to see right now, and the learning rate. And this is like mostly guessing games, which parameter is more adequate. So I'm going to show you how you can find the optimal solution. It's called the Keras tuner. Keras tuner. So if you want to know the number of epochs, the batch size, the hidden units, the dropout rates, the label smoothing, and the learning rate, if you're going to do it by yourself, you're going to guess it. So the best thing is to use Keras tuner. In here, they're going to build the model based on your data, and then they have a random search. You're going to put the parameters that you expect they're going to be good. Like hidden units, you can start by 20, like 128 until 512. and it's gonna randomly search which one is the best. And then it's gonna give you the best iteration. In here, best model, tuner, get best models. And from this, I've got these values. And these values are the same in the one that I have shared with you in here. It's from the GitHub. And that's why I told you it would take a couple of months to do this kind of thing. So it's impossible to do everything in 2 hours. You can use NumPy where you condition. Yeah, that's smart. Yeah. A lot of people are using that kind of thing. They encode the data using NumPy condition. Now let's run the model. Yeah, go ahead.
Do we still have other coding parts to go through, or
no? This is the last one.
Because we still need time for the Kahoot quiz, and we're running out of time basically. So.
Yeah, of course. This is the last one. So
okay, great.
We have the classifier, create the MLP, which stands for multi-layer perceptron, number of colors, labels, hidden units, the things that we have gone through. So this will actually create the model that we talked about based on the data we have scraped. And then we're going to fit it. Fit the model, we have put the data we have. It's going to learn based on X train, Y train for a number of epoch, which is 50. And let's see how many have survived until now. 18.
Yeah.
Okay, good. Please don't forget to share the scraping. Yeah, of course. I'm gonna share it. They are actually on on GitHub, but I have changed a couple of things. So yeah, definitely I will put the updates. So congratulations, guys, for staying with me during 2 hours, and this is the result. Shift Enter, and boom, epoch 1. We have the loss of 07, 06, and the loss is getting smaller, then bigger, then smaller. So the model is unstable. The model have learned for 50 epochs, and we have the loss function that have dropped. But the mistake is the area under curve is giving me 0 in all the epochs. So it's up to you guys to discover where this did go wrong. Because live coding and thinking at the same time to get it done in 2 hours is not nearly to impossible, but it's really demanding. For me, what I'm gonna do, like spend a couple of more days to figure out the better model, and like based on the discussion with Ihab, I'm gonna try to add and take some part of this, and definitely change the sigmoid part and the binary cross entropy, because this is more suitable for classification. We will try to make it more suitable for regression. Yet, the last line of code is the prediction. I'm going to show you how with that code for classification, I can have a prediction. Because in real life, you're going to have a buy or sell order, 0 or 1. 1 is sell and 0 is buy, whatever floats your boat. So now I'm going to make the prediction on my unseen data. So you remember this table? I'm going to put the X test, and I'm going to predict the Y test. Hopefully it works. CLF fit. Hopefully. Okay. It has worked. So now we have given it the X test, and it's going to give me the Y. So the model did not see the data in yellow, so now it's going to give me the predictions. And this is what it did. These are, I think, 212 data points. Now the value of Tunisia is 560 million. Let's go to Tunisia and see the value of the last date. El Bursa. Actually, I have it in the file. Tunisia. Okay. Ouverture au bas, volume dernier. Volume titre, volume dernier. Okay. $570 million. Is it close? 561 million. Not bad.
Yeah, almost.
Yeah, not that great and not that bad. And by the way, this is not even customized for regression, because what we usually do is classify if we're gonna sell or buy. So I'm gonna share the source code. It has a couple of mistakes and it has a lot of things you can improve on. And I will keep my my good notebooks private. Why I will do that is so people do not copy paste good results and pretend it's their work. And I know a lot of students have a lot of projects and graduation projects, so they will take advantage of that, which will be cheating. So this is me doing live coding, at least some parts. Hopefully you liked it. It gave us very close results. Let's check with the day before. 563 million. I don't know if it's good. Tunisia. Let's see. 17. Let's see. So we have seen Friday. So Friday is 5.7. And Thursday is 5.7. So Friday is 5.7 and Thursday is 5.7. And in here we have 5.63 and 5.6. Actually, this is, oh no. 5.61, 5.61. It's really close. So last week we have 5.7, 5.7, and 5.7. We should have 5.61, 5.61, 5.61, and 5.62. Yeah, not that bad. I'm not satisfied. I really encourage you to correct the mistakes I have done on live, and I really encourage you to improve the code and change this part to make it more suitable for regression instead of classification. So thank you so much, guys, for being with me, trying not to embarrass myself on live. And now if you have questions, please feel free. Otherwise, we're going to move on to a very quick Kahoot.
Muwafaq, I put you some comments in the discussion.
Okay, because we have the lowest and the higher price of the same idea, and we shouldn't assume the opening price is okay to have it available.
Actually, before I said something else. I said that there is a look ahead bias, and this is the reason why the prediction was so close to the true value.
Yeah, so the look ahead bias, you can escape it by using time series. This is a technique for grouping the data adequately. It's used on sklearn, but it's not official. You only can get the source code from GitHub, and
Can you write it, please, on the discussion?
I'm gonna first. Actually, I have the link inside the GitHub. So you go back just to the GitHub in here, and I have the link to the Peugeot time series. It's the most efficient thing, and it was really discovered on the last competition.
Yeah, but anyway, we have a look at BS because we should not have the lower and the highest price of as feature actually of the same day.
Yeah, it kind of makes sense. But sometimes you can have the lowest and the highest, and you still will not predict the closing price.
You try to have a look to the to the historical prices, and you will see that they are too close to each other.
Yeah, they are too close. But look, what we did is like the last 20.
Yeah.
Let me show you something. The data, like the last 20% of the data was unseen. Okay, they know the opening and
Exactly.
but it does not really. It influences the result.
Believe me, it influences a lot. Believe me.
Yeah, it influences the result. Yeah, there's something to test. So what we're gonna, at least you're gonna do, is drop the features from here. So you drop the opening.
Actually, what we should do in the reality is to create other features, like, for example, technical analysis features, you know?
What I do when I have a lot of features, I do embeddings.
You do what, sorry?
I do embeddings.
Embedding.
So what I do, you do not do your technical analysis to create your own features because that's useless. And this is like a very advanced subject. So you have a higher dimensional kind of features, and you're going to project them to a lower dimensional feature. This is like the real deep learning. And then you combine the deep learning part with the wide learning. You use the embedding part and you combine it with the wide part. And that's how you get new features that are useful to your model. So the opening and the high and the low of the day, they're going to be embedded into a lower dimension. So I don't do it manually. You can have a neural network to do the embeddings for you, and then you create your new features. And like I said, once again, just go back to the GitHub in here. I'm going to open the link. And you're gonna see it for yourself. So
you said wide learning.
Yeah, wide learning, embedding deep and wide learning.
Wide or wide, like large?
With a D, yeah, large. So this is the fast AI. Like one of you have said something about fast AI. So Ali Dean.
Can you write it down, Muwaffaq? If it's not clear, just write it down.
Okay, deep and wide learning. So for the first AI thing, I find a code that they know how to do embeddings and how to smooth the data, and it's in here. Inference, fast AI, embedding, smoothing. So you do not create your own features because it's almost impossible, especially if you do not know what those features are. In the competition, they do not tell you what those features are. You need to solve your black box by a black box. So just click on the link and you're gonna find a wonderful world of approaches. And this is with Fast AI. And Fast AI is the simplest way to implement the model, and it's still really complex. Like even for me, it takes a couple of months to replicate what I have found in here. It's really it's really intriguing. And then you can find the part that we have done in the workshop. And this part is used from another notebook, and we have kept looking for the best thing. And then the final one is on the leaderboard. It's called Yurin Zhang. Is a friend of mine on LinkedIn, and he told me they have ranked second, and they told me they have combined embeddings with PyTorch with an XGBoost model. So in here we learn a very valuable lesson. Yeah. Yeah, go ahead.
Okay, sorry, sorry for cutting you off again.
Yeah, it's okay.
I think we can't be allowing any more questions because we're really running out of time. So, like, if there are any questions, they will be answered in the Kahoot quiz, right? Which we'll be doing right away.
So let's open Kahoot.
Great.
It's very simple.
So,
they are now.
Sorry again, guys, but we really have a time constraint, so we can't really have that many questions. We're happy for that, by the way. It shows interest. But okay, so for those who don't know what a Kahoot is, you can log in to kahoot.it through your device, either phone or computer. And basically, since Muwaffaq is sharing his screen, you're going to be seeing the questions, and you'll be answering through the device, through your device, either your phone or your computer. And whomever collects the highest number of points is basically the winner. Yeah. So yeah.
So guys, do not be afraid of the quiz. It's just for fun. There are no in-depth questions, but they are subjects that I did not talk about during the workshop. So I wanted to provoke them during the Kahoot, but it's going to be brief because we have the past 2 hours. And it's going to be another additional 5 minutes. So just go to kahoot.it and DataGad. Are Google engineers a joke to you? So you write DataGad. So you just go to kahoot.it and you put the game pin, and that's it. You choose a funny name. How many survivors? 17. Yeah. So it's the half. We started with 33, now 17. Yeah. Good. I wish I had gifts for you guys, but yeah, actually I have stickers. I have new stickers. I thought I threw them into the trash, but I found them. Okay, DataGad, is that Ihab? I think it's Taha.
No, it's not.
Who's the DataGad?
DataGad. No, it's not me.
It's Jim Simons.
Oh, Jim Simons does not use machine learning, my dear. DT 11 p.m. What does that even mean?
Deep trading 11 p.m.
What?
Deep trading.
Oh, Tinder. Tinder chicken or the Tinder application? Yeah, I think I should install Tinder. Good reminder. Come on, guys, we need 10 people. Yeah, I got your message on LinkedIn.
Yep.
Please don't tell me to share with you my private notebooks, because I will not do that.
What did you say?
I told you, please don't tell me to share with you my private notebooks, because I need to be rich first, then I will give you my.
No. Just what you have done today. That's it.
What I have done in what?
Just what you have done today. I mean, on in the workshop.
What you covered in the workshop.
Yeah, okay, keep on texting me while waiting for the other guys. Guys, like, you can use your mobile phones, you can use your laptops. It's really fun.
Okay.
Come on.